All right. Hello, everybody in Confirm NYC land. Welcome to the 3 o'clock session. I had to double check the time there. The 3 o'clock session for the green track. You are in the session called Web3 Identity and Data Management with our speaker Val Mack. Those of you who don't know what Web3 is, well, you're going to find out. But it's the basis. Web 3.0 is the basis of the decentralized web. That is founded in blockchain technology. And in a couple of minutes, Val is going to come on and tell you all about what that is and why it's so important to identity and data management needs of tomorrow, and how tomorrow's technology is going to be built on it. You can ask questions throughout. Val will be good enough to check the feed and answer questions as they come in. We'll do our best to curate those so that they're relevant and Val gets a chance to answer them. But please feel free to ask questions through your chat, through the chat window. And before we get started, I want to say a couple of things about our session sponsor. Our sponsor today is Legal RM. And for those of you that don't know, Legal RM is the company behind I Comply, which is the logo that you've seen in some of our sponsor-related materials. And Legal RM is the leading. I Comply is the leading information governance and records management system that's used in some of the world's largest law firms around today. The company, Legal RM, partners closely with their clients just to ensure that their product works the way that the clients work, right? It works the way that they work. So Legal RM as a company has more than 60 years of collective IG and records management experience to ensure that I Comply meets the needs of clients now and in the future. And iComply is available for both cloud and on-prem deployments and offers one of the industry's most robust APIs to provide IG compliance across the entire enterprise. And this is a good segue because speaking of APIs, we've got somebody who's quite technical. It's going to talk, unpack all that stuff for you. It's my pleasure to bring on stage at this point Val. Val Mack is, so Val and I, hi Val, welcome. So Val and I got introduced actually through a blockchain development boot camp that we were both in. And I learned subsequently that Val is actually a full-blown Web3 software engineer and smart contract developer. And she's currently helping to build a free and open source peer-to-peer data management protocol called Ceramic Network. It's spearheaded by 3box Labs, a New York City startup. And she's a Cornell graduate with undergrad and master's degrees in computer and information sciences. And when Val's not coding, which is, I don't know if this is ever, it's kind of hard to understand when you wouldn't be coding, but when she's not, she runs Festival Labs, or I guess it's Festival Labs, right? That's probably the right way to describe it. Festival Labs, it's a consulting company that helps developers build compassionate technologies. Look up her full profile. There's much more there, boot camps and accelerators and mentorship, but I don't want to take away any more time than we have to. So without further delay, please welcome our presenter, Val Mack.
Thanks so much, Gene. Appreciate the intro there. So yeah, thank you, Arma, for having me. I'm really excited to be here. I'm looking forward to sharing with you what Web3 is, all about this space. So today I'm going to be talking about Web3 identity and data management, and let's just jump right in. All right, so you already kind of got the intro on me. Just to round it off a bit, again, I am Val. I'm a Web3 software engineer. So my background, I started studying information science at Cornell. And basically information science for me was a lot of human-computer interaction research, as well as data analytics and data science. So that's kind of how I got my foundations and my first real interest in tech. From there, I moved on to my first job at Verizon. I was doing product engineering there in their innovation lab. And really, that's where I started to deep dive into Bitcoin, blockchain, cryptocurrencies, all of that stuff. So from my experiences being in Verizon, I ended up moving to the SF Bay Area, San Francisco. And so when I moved to San Francisco, this is around 2017, coming on to 2018. This was a time when we saw the first real spike of the Bitcoin market price, and a ton of other cryptocurrencies too. So at this time, Bitcoin and crypto was all anyone ever talked about. And that's how I really started diving in to understand kind of the underlying technology behind it. That led me to working with startups in the SF Bay Area, helping them build blockchain applications and cryptocurrency applications. And eventually it led me to my current position, which is at 3Box Labs. So we're an NYC-based startup, but we're distributed all over the world. And we're working on this peer-to-peer protocol called Ceramic Network. And I'll talk about that a little bit later in this talk. So that's kind of where we're at now, and that's me. So let's start talking about Web3. In order to do that, we really have to start by talking about Web2. So getting a solid understanding of what Web2 is, and that kind of informs what Web3 is today and what it will be in the future. So Web2 is just the internet that we interact with today on a day-to-day basis. So in the Web2 kind of paradigm, we have this really highly directional flow of information. So as an end user, an individual like me and you, we're creating information, user-generated content. We're creating this information, we're sharing it with our friends, with our family members, random people online, and we're also sharing information with applications. And a lot of that information exchange is going through Facebook. So, creating content there, but also Facebook is a place where we're consuming a lot of content. And when I'm speaking about Facebook, I'm kind of talking broadly about the different applications that they have. So that includes Facebook.com, but also WhatsApp and Instagram. So all of these kind of like most major social channels where information is being exchanged. And then of course we have Google, where we're getting a lot of that consumption as well. And we're kind of able to like discover all of this information. And of course, Google, they hold a ton of other properties that allows people to share information, not only as individuals, but between different enterprises and different institutions. And so really they, have another major piece of this kind of Web2 puzzle. And then we also have Amazon, of course, because that is where most of this data is living. So, created through users, created through applications, and then hosted on Amazon servers. And so I really focus on these three companies because in full honesty, they are kind of taking up most of the market share and really provide the software for most of the applications that we're interfacing with day to day, whether it's at the consumer level or at the enterprise level. They kind of facilitate all of this. And so I kind of like to think of this topology here as like a Bermuda Triangle. And we all kind of just live inside of this Bermuda Triangle where we don't really have a good sense of what the data is that's being exchanged. We don't have a sense of who it's going to, where it lives, or even like the shape of the data and how it can be used. And so it's very opaque inside of this kind of system. And that's mostly because the data is living in these silos. So an organization, has their own data, they have their own data format, but it kind of just lives within whatever servers they are using for that information. So there's not really a great flow and exchange of information in this paradigm. So when we look at Web3, we see like a completely different topology. Instead of having major players or major nodes in the network, three major nodes, we have a series of them. We have thousands of them, millions of them. And so the Web3 topology is really one in which anyone can be a node. So it could be an individual at their laptop, it could be a company, it could be a government institution, and everyone kind of participates in this network on a more even playing field. So all of these nodes are directly connecting to each other in a peer-to-peer fashion. And this, one way to also like consider this network is the fact that it is truly global and truly distributed. So this network can, exist all over the world, and anyone has the ability to participate in it. Okay, so that's the topology of Web3. And now to kind of like dive into like, what does Web3 really mean? What are the components of it? It's really important for us to think about kind of the origins of this. So we're starting at Bitcoin. Bitcoin, the white paper for Bitcoin was released in 2008. But the origins of Web3 definitely predate that. But Bitcoin is a really good starting point because it was the first like practical implementation of a network like this. So someone asked, this is interesting, can nodes be mapped? Yeah, so in this topology of Web3 and in Bitcoin, for example, all of the actors can be recognized and you communicate with them directly. So you can discover these different nodes and you can start to kind of visualize this topology actually in real time of who are the different nodes and who are the people who are contributing to this network. So again, kind of using Bitcoin as an example, it's the first like practical time that we like see this happening. We see people participating in this peer-to-peer network, fully decentralized, and they're able to actually sustain the network over time. And so that's really like where the innovation with Bitcoin is coming from. So on one level, you have this peer-to-peer payment system. So you basically have someone, Alex is sending 5 Bitcoin to Beth, right? So we now have digital cash. But in addition to that, we have this network that is also backed by this cryptocurrency as well. So we now have this distributed database, and just moving to the next slide, the distributed database, which is allowing us to maintain the ledger of all of these transactions as people are exchanging this monetary value. So really the data structure that kind of underlies Bitcoin is a blockchain. And a blockchain is essentially this decentralized distributed database. Every node that participates in the network keeps a copy of that ledger, and all of these nodes share in the responsibility of verifying the integrity of the data. And so now this kind of brings me to a really important point of the Web3 ecosystem, which is cryptography. So cryptography, it's a field of mathematics that's been used, in the internet for a long time, not specific to Web3. But in the Web3 ecosystem, cryptography is really a native piece to all of the interactions. So all of these nodes who are participating in blockchain, they're taking a copy of this ledger and they're using cryptographic hash functions to verify this data, which allows you to add to the security of the entire system. And so you have nodes that have keys, public and private cryptographic key pairs, and they are able to, put transactions into this ledger. So they're able to exchange this value, but they can also verify the data that's being there. So this is a really innovative aspect of this, because again, we didn't have a practical way to do this until we introduced the cryptocurrency on top of the peer-to-peer network. And so it's important also to understand that Bitcoin kind of serves this dual purpose. It acts as a way to exchange value, and it acts as a way to incentivize the network. And from this model of Bitcoin, people were able to come up with, different types of blockchains that were able to serve a similar mission of sharing data in this decentralized way. And so that brings us to Ethereum. So Ethereum is another blockchain. It was conceived around 2013. The technical paper came out the following year in 2014. And then in 2015, I believe, the network went live. And Ethereum, again, it's another blockchain. It also has a cryptocurrency attached to it called Ether. So it's very similar to Bitcoin in some ways. But the aims of Ethereum were to create this global distributed computer. And that's still the aim of Ethereum today. So the model is different in that we're no longer just verifying a ledger that has, these transactions of this person sending funds to this person, but now this network is designed to verify computation. So when you participate in the Ethereum network as a node, you receive these inputs and you have an algorithm. And basically you're verifying that, when those inputs go through that algorithm, you get a certain output. So every node in that network is doing the same verification of that computation. And again, they're incentivized to participate in this network by receiving a reward of the token, which is Ether. And so now we have this self-sustaining network where people are incentivized to follow the protocol in a way that ensures the security of the protocol. But Ethereum, again, it's different because you're verifying computation, which allows you to make like super cool applications on top of this. And what we realized through kind of like Ethereum's development and maturity, and I say maturity, but it's still very young, obviously, just starting in 2014. But what we realized is that one of the like killer applications that could be built on top of Ethereum was actually new tokens. So now, like, it was no longer just the token that's associated with the layer one blockchain, whether it's the Bitcoin token on top of the Bitcoin blockchain or the Ether token on top of the Ethereum blockchain. But we are actually able to create new tokens on top of Ethereum. And so that is kind of what led to what was called like the ICO craze. So this is, again, around like 2017, 2018, people started doing initial coin offerings where they would basically create a contract, which is just some code that sits on Ethereum that mints a new token. And then, you're then able to exchange that token and sell that token and all of this. But that's like one of the powerful things that you can do with this blockchain property. And again, like you have to have that incentivized network to have the security to enable these applications to be built on top. So one of the kind of bottlenecks that we found in the Ethereum chain is scalability. So we don't have the ability to just put arbitrary data on chain on Ethereum because it gets really expensive to do so. It just was not designed to be optimized for that purpose of, like, for example, storing an image. It's not really realistic to store an image directly on the Ethereum chain. But fortunately, we have other technologies that can kind of serve those purposes. So this brings us to IPFS. Around the same time that Ethereum was developed, 2014, IPFS, the Interplanetary File System, as its full name is, was created through the Y Combinator Accelerator Program. And so IPFS is specifically designed for peer-to-peer file sharing on an interplanetary scale. And the really cool thing about this is, like, now we have a way to use, again, those cryptographic primitives to verify data that's being shared between peers. Again, like, a peer can be an individual person at their computer, or it can be an enterprise, or it can be a government institution, it can be anyone. But everyone has the equal ability and equal access to participate evenly in this network. So with IPFS, what we're doing is we're taking an image, for example, we're running that through a cryptographic hash function, and out we get a content identifier, or CID. And what this enables is sharing these content identifiers between everyone in the network. And it gives us the ability to say, okay, when I receive this data, now I have a very easy way to identify this data. And it's a very compact way as well. I just get a string of letters and numbers that are this content identifier that maps to a specific piece of data. So that's what IPFS enables. And now you can imagine if we take these two kind of different networks and these two different architectures and merge them together, we start to get like really interesting properties. And so on this slide here, I'm basically showing, in the Web3 ecosystem, we have different networks that are running simultaneously, but that also can communicate with each other. And so we start getting linked data. That's how we refer to it in the space. So as an example, if I wanted to create a blog and upload it to IPFS, all I have to do is run the IPFS software on my computer. I publish my blog and I share that with the entire network. Another person who connects to IPFS can grab the content identifiers, download my blog contents, and read it. So it's super easy to do that, and we have the protocols that enable anyone to access that information. And now I can kind of take that a step further, and I can make a claim to say, I am the owner of this blog content. So I have my cryptographic key pairs, and I can take those and use those CIDs and put them on the Ethereum blockchain. And so I sign a transaction that's stored on Ethereum, and that transaction basically just says this key pair, my pseudonym essentially, is the owner of these content identifiers for this blog. And so that means that anyone on the Ethereum network can now see that, and they can look at those content identifiers and know exactly where to find them on IPFS. And then similarly on IPFS, I can store the transaction ID of the transaction that I put on Ethereum. And so anyone in the IPFS network can now look at that file in IPFS, they can see the transaction ID, and they can know, oh, okay, this pseudonym has a claim to this content, and they're saying they're the creator of this content. So I have a really seamless interoperability between these different networks. And that's another key characteristic of the Web3 ecosystem. All of this technology is being built on the protocol level to interoperate with each other and to allow applications to read data back and forth between the different networks. Okay, so that's another kind of aspect of Web3, and that's another aspect that we have, which is linked data. But I want to point out also that IPFS kind of has, thanks for the comment, Marshall. IPFS kind of has this property that Ethereum doesn't, and Ethereum also has the property that IPFS doesn't. So Ethereum has this incentivized network, as we mentioned before, and IPFS doesn't have that. So what we can do is actually use Ethereum as a way to incentivize people to host content on IPFS. So as an example, if I am running this node on my own laptop where I'm sharing my blog, if my computer dies or my power cuts off, then I'm no longer sharing that content with the network. And if no one else is storing a copy of my blog, then essentially that blog content gets completely removed from the network. But what I can do is now use these cryptocurrency-backed layers to incentivize people to actually keep that content up. And share data in that way. And so now we get a reasonable way to actually scale file sharing in this peer-to-peer ecosystem as well. Okay, great. And so I want to talk a little bit about like applications that have been built on some of this technology. And a really cool one is Starling Lab. I just recently found out about Starling, and they're doing some awesome stuff. So basically their mission is to record things that are happening in human history, specifically human rights violations, accounts of genocide happening in the world, things like that. So they're recording this information, working with journalists to capture it, and they're actually storing this information in the Web3 ecosystem. So they put the records, the photographs in IPFS, and they take those content identifiers and they do what's called anchoring. And so they basically do exactly what I mentioned in the blog example, put those content identifiers on the Ethereum network. And once those identifiers get placed in Ethereum, they now are permanently recorded there. And they're verified, by the security of the network. So now we have a way to verify this content and to persist this content over time that's relevant to everyone in the globe. And everyone in the globe also has access, equal access to the information. So that's just one of the cool applications that people are working on with these technologies. All right, and so in these examples that I've given now, I've talked a lot about the different actors who are participating in this network. So me putting my blog up, Starling Lab working with journalists to put their content up, enterprises, companies, institutions, academic institutions. All of these actors are also nodes in this network. And in the Web3 ecosystem, we have another native way to represent these actors in the space. And so we use what's called DIDs. They're called decentralized identifiers. And DIDs basically are kind of like a wrapper around the cryptographic key pairs that people use to do these different actions, whether it's sending a transaction, uploading some content, sharing content. And so when we have a DID, we now have a pseudonym, and that is an identity for different pieces of content. What that enables is things like access control. So any individual actor now has the ability to generate their own content. They can see exactly where it goes, but they can also delegate who has access to that content by using their cryptographic key pair. So this is an important point, which is really relevant to enterprises, to healthcare, for example, different government entities, where we can now encrypt our content natively at a native layer. And when I say that, what I really mean is that individuals like you and me have the ability to do this without needing to go through complicated software stacks, or have this facilitated by a third party. Like, we natively can just encrypt any content that we want, and then we can say who has access to that content. And so DIDs are kind of the abstraction that are used natively in the Web3 ecosystem to facilitate this kind of behavior. Okay, great. So I feel like I talked a lot, and I probably talked pretty fast, but I want to take a few moments also to talk about Ceramic Network, the work that my team is doing to contribute to this peer-to-peer protocol, and how this kind of fits together. So I mentioned a few different pieces, IPFS, right? I mentioned Ethereum, these different blockchains, Bitcoin, and different kind of ways that we can connect this information. And what we're doing with Ceramic is essentially creating a management tier for all of these protocols. So with the Ceramic protocol, you get a DID. So you get this identifier and you get this key pair, and we kind of facilitate the management of your data. So whether it's updating content over time, delegating access to that content, as I mentioned, through an ACL type structure, we kind of are creating the tools that make it really easy for people to do this. And as you can see in the slide here, we have this like tagline, like moving the world's data beyond the cloud. And I think that's really representative of the Web3 ecosystem as a whole. It's no longer about just putting something in the cloud, which is essentially putting something on Amazon, and putting it in a silo, but it's disseminating this data in a peer-to-peer network, but in a way that is most beneficial for your application's needs and for the end user needs. So again, like, every single person and every single entity in this network has equal access to these technologies. And with this DID abstraction and the management layer on top of that, now we can just all seamlessly interoperate, which brings really exciting opportunities for the future in terms of how applications treat their end users, and also how applications work with each other, with native ways to read each other's data, and to use that in this global network. So yeah, that's basically it for the information that I have. I'm really excited to take any questions that are left here. And feel free to follow up with me, connect with me on Twitter. I'm at CodeValTweets, on LinkedIn, ValMac. And thanks again, Arma, for having me. This is really great. Okay, so question, will regulations be developed? Are there possibilities to spot misinformation? Okay, so first, in terms of regulations. So I think that in Europe, in the UK, they're doing a pretty good job of setting some of the regulations that are in particular going to be helpful for end users. But one of the exciting things about the Web3 space is that, as I mentioned in the DIDs, if I can go back here, is that the kind of access control, again, is contained in this DID layer. So that means that end users have more control over their data, and they also have the ability to easily see where that data is going. And that, so far, or at least in today's paradigms, that definitely is much more compliant with the regulation in Europe. And in the US, I think we have a long way to go in terms of providing good regulation there. But I will point out also that all of these protocols are open source. And what that means is that if there are needs for different types of networks that have different properties, so for example, a closed network, that's just, let's say, a few banks want to run this software in a closed environment, they have the ability to do that. The second part of the question, I think, was about data integrity or spotting misinformation. Yeah, there we go. Thank you. So are there possibilities to spot misinformation? So there are ways that people are kind of designing some protocols such that you can contest information. Um, Very similar to what we have in the Web 2 paradigm, where you can just put anything out there and you can't really verify it. We're creating some protocols where you can share information but also contest it, and you have this kind of like consensus layer that lives underneath everything, that ensures that data is verified and the integrity of it. So basically, it's like we have to come to an agreement about what this data actually is, and if it means what the person who created it says it means. And then we have ways to kind of handle it if it turns out that this information is incorrect. Great question. Yeah, thank you, Samantha. I was really happy to be here.
Yeah, I popped up because I want to second Samantha's comment there. It really is interesting stuff, and it's actually, the more you look into it, the more you learn about it, and the more you're involved in the community. That it's such an opening and welcome community. It's really intoxicating. I mean, you really begin to see the possibilities of what tomorrow could bring and what could happen. And I think one of the great things that Val did here today was really break it down for us and really kind of set that metaphor to explain the fact that everything you've heard about blockchains, everything you think you know about blockchains, yes, it's technically complex, but at the end of the day, it's really a database. So rather than thinking about a database like a SQL Server and Oracle residing on a server somewhere, think of the world as your database, the different computers that comprise the network as your global database. And the same thing with the virtual machine, right? The Ethereum VM. Rather than one motherboard and one processor, think of the entire world being one giant computer. And essentially, that's what this community and this ecosystem is trying to build. We've got another question here from Ruth.
Would there be possibilities to engage professions such as librarians? Absolutely. I think that, like I mentioned with some of these protocols, like IPFS in particular, any data can be stored there. Anything that you can imagine can be stored there. And so I think that it's going to be really essential for us to have professionals in different spaces to inform the designs of some of the abstractions and applications that are built on top of this. And I think actually that it's a great question, because I think that's one of the areas where the Web3 ecosystem is really lacking right now. Like, we have a lot of people who kind of understand the fundamentals to distributed systems, to internet networking, but we really need like more people who understand the application layer and some of the implications of the way that this technology is designed. But one of the really beneficial things is that because it's such an open network, it's a peer-to-peer direct network. The end users who are people of all different types of professions, doctors, librarians, whatever profession you are, they have the ability to actually inform how the network is shaped. And so when we introduce this currency, you actually have the ability to kind of say, this is something that I want to back with my monetary value, and this is something I want to support with that monetary value. And that kind of plays into how things are designed in the system. And again, like in the Web2 world, we just don't have the ability to do that, because you don't have an identity that allows you access to the API layer of these different applications. But in Web3, it's seamless to do that. So I'm super excited to like get more people of these different professions learning about this and giving their feedback and insight, so that we can actually build like better protocols that really meet the needs of everyone.
Yeah, great question and great answer there as well. I like also Ceramic's tagline, with the going beyond the cloud, because I think, I think that beyond the cloud vision is really kind of is a realization of what people may have thought the cloud would be when the cloud first came out and became the cloud. But, essentially you realize that you're not really in the cloud, you're in kind of a data center, maybe in one or broken up into a couple of giant data centers. And that's the cloud. That shouldn't be, right? The cloud really should be the cloud out there in the ether and distributed and with safety mechanisms and all the protocols that you mentioned in place. And that's what's really exciting about this as it's being built. I've got a question for you, Val.
Yeah, for sure.
You mentioned that sort of that marriage of the Ethereum VM and IPFS as a file storage system. Would it be right to look at Filecoin as kind of a marriage of those two? One of the implementations of that marriage?
Yeah, exactly.
For those that don't know.
Yeah, I didn't mention Filecoin here, but yeah, Filecoin is basically a way to keep persistence of the IPFS data. And so yeah, Filecoin is one implementation of that. But there are other implementations that are being built that can do similar things. But yeah, you do need to have when you're keeping large amounts of records, like you do need to have a way to actually persist those over time. And so people are kind of creating the bridges to do that, and Filecoin is one of them.
Awesome.
Yeah, so this other question, would this be a future part of library science departments? That's a great question. I think that because of the way in which you can store and manage information through systems like this, I definitely imagine that would be the case, especially as you're talking about new forms of research being generated. So as an example, there's a company called Research Hub that has a kind of crypto blockchain backed layer to it. But their aim is to facilitate research by using technologies like this in the Web3 ecosystem. And so what they're doing is kind of creating a navigation system for people to find new research, discuss it, and also support it through like grants and things like that. And so I think that, as more information gets on the Web3 ecosystem and on platforms like this, it's going to be really important for, in particular, like people in academia to be able to easily retrieve these things and use them to inform the research that they're doing. And for that reason, I would say, yeah, in terms of like this being incorporated in libraries, I think that could be really helpful.
Yeah, I think, just I get people say this all the time, but like think back to the world pre-internet, right? Like, and the questions that people were asking, like, would library sciences be affected by the internet? Of course, everything's affected. I think this is kind of like that next generation leap where everything is kind of at some point there's going to be a decentralized subtext to a lot of the things that we take for granted today.
Right. Yeah. Yeah, and I mean, I think, especially when you're thinking about like academic research and things like that, it's really powerful to be able to disseminate information in this way. I mean, there's a lot of kind of nuance to that as well. But right now, if you're not hooked up to a certain library or a certain institution, it can be difficult to get some information that could be really helpful to you. And so Web3 is kind of saying like, well, are there ways that we can do this differently so that we can, give more people access to all of this?
Yeah. Linked data is buzzword in library cataloging too. Oh, yes, that's true. Yeah.
Yeah, I think there are a lot of like ties to linked data, semantic web, things that like I feel like people have been kind of noodling on for a while, but we haven't really seen them manifested yet. So yeah, definitely strong ties there.
Yeah. Well, listen, there's if this was a bidirectional sound system, you'd be hearing thunderous applause. But I'll convey some of the thanks that you're getting. So on behalf of everybody and on behalf of the board of directors of ARMA Metro New York, thank you so much, Val, for sharing your expertise and your time with us here today. Val's a first-time speaker on the ARMA circuit, but I get a feeling it's not going to be the last time that she's asked to present.
Yeah, I hope so.
Thank you so much. This was amazing, everything that I was hoping it would be. And before we go, I also just I'm going to get back and repost Donda's post here, because equally we want to thank our sponsor, Legal RM. Without their support and without the support of all our sponsors, this wouldn't be possible. So check them out in our sponsors catalog. And we still got a couple minutes, but keep in mind we have our track at 4 o'clock, and please stick around for the 5 o'clock networking and trivia game. Val, thank you once again, and take care, everyone.
Bye.
Thank you for joining us. Bye-bye.